Connecting standard form and vertex form. Partial factoring. Our learning goal today is to partial factor to solve unfactorable quadratics and convert from standard to vertex form. Please ensure you have the lesson printout so you can follow along with this video. Partial factoring. Partial factoring allows us to more quickly solve for the vertex than regular factoring. As you recall from our last lesson, to find the vertex when we're given the standard form of an equation, what we had to do was fully factor it, then solve for our x's, solve for our midpoint, plug that back into our original equation, and then get the y value of the vertex. Partial factoring allows us to do this a little bit more quickly, and it also helps us to find the vertex when the standard equation cannot be factored by regular means. To quickly determine the axis of symmetry, our h value, we can use the technique known as partial factoring. Recall, once you have the value of the axis of symmetry, remember it is the x-coordinate of the vertex, all you must do to find the y-coordinate is plug it in to the known expression and solve for y. So let's take a look at this technique. So I will now show you the technique of partial factoring. Example 1. Determine the maximum value of the quadratic relation y is equal to negative 3x squared plus 12x plus 29. What we can see is that this is in standard form, and we know in standard form it looks like ax squared plus bx plus c. And so for step 1, we want to common factor the first two terms, negative 3x squared plus 12x. So let's rewrite the equation here. Y is equal to negative 3x squared plus 12x plus 29. And we're going to common factor these first two terms here. So out of both of these terms, we can take out a negative 3 and an x. Left inside our brackets would be x minus 4. So that's our first step. We factor the first two terms. Step 2. We're going to set y to c and solve for zeros. So this is what we're going to do. So let's rewrite what we have here. Y is equal to negative 3x bracket x minus 4 plus 29. And so what we're going to do is we're going to set our y value to 29. And then what we're going to do is we're going to move this 29 to the other side. So it's going to cancel out that y at 29. So we get 29 minus 29 is equal to negative 3x bracket x minus 4. So this is going to equal 0, and we're going to be left with this expression. 0 is equal to negative 3x bracket x minus 4. And this is very similar to something we've seen before. This can give us our zeros. So for this statement to be true, either negative 3x is going to equal to 0, or x minus 4 is going to be equal to 0. Now we can solve for our zeros. So one of them, x, is just going to be equal to 0. And our other one is going to be x is equal to positive 4. So now we have our zeros. So I just want to make a correction. These values here are not actually our x-intercepts. So don't copy this down. I'm just going to show you this. So when we do this calculation and we get these numbers here, these are just two values that are opposite each other on the parabola. They're not necessarily our x-intercepts. They allow us to still calculate the axis of symmetry, but they are not the x-intercepts, okay? So they're not these values. Just to let you know. Now back to our regularly scheduled program. So now we have our zeros. Let's use the midpoint formula and solve for the axis of symmetry. So we know x mid is equal to x1 plus x2 divided by 2. And in this case, x mid is equal to 0 plus 4 divided by 2. And 0 plus 4, that's just 4. So x mid is equal to 4 over 2, which is equal to 2. So our x mid, which is equal to 2, which is also equal to h, our h value of our vertex. In step 4, we want to plug in our x mid value into our original equation and solve for our vertex. So let's go ahead and do that. So we can see our original equation looks like this. Y is equal to negative 3x squared plus 12x plus 29. And so we know our x value of our vertex is 2. So we're going to plug that into here to get our y coordinate. So let's go ahead and do that. So we'll simplify this here. So it's going to be negative 3. 2 squared is going to be 4. We'll do this one right over here. So 12 times 2, that's positive 24. And this is 29. Okay, and so we're just going to multiply this here. So y is equal to negative 3 times 4, which is negative 12 plus 24 plus 29. Okay, and then what we're going to do is just add these up together. So 24 plus negative 12, that's just going to be y is equal to positive 12 plus 29. And so when we add these together, we're going to get our y value of our vertex, which is going to be 41. So we know our vertex now is at 2, 41. And once we have the vertex, we can see that we know the A already. So if you wanted to get to vertex form, it'll be very simple from this point. So this is partial factoring. One thing to note, if we look at the original formula here, if we tried to factor that, we'd have to multiply negative 3 times 29, go through all the multiples and try to figure out two numbers that multiply to A times C and add up to B. It'll take a longer process, and it may not even be factorable. We might not even have factors that will work out for this one. So partial factoring eliminates that, and we're able to get to our vertex without having to factor that directly. So we're going to try another example of partial factoring here. In example 2, it says express the quadratic y is equal to 2x squared plus 8x plus 5 in vertex form, then sketch the graph of this relation. So you may be tempted just to try to factor this. And so let's go ahead and try that. We have A and C here. So if we're going to try to factor this, we have to find a number that multiplies to A times C. In this case, A times C is going to be 2 times 5, which is 10. So it has to multiply to 10 and then add up to 8. And if you think about it, if you go through all the different factors, you'll see that there are no whole numbers that can do that. So we can't use that method here. But we could use partial factoring. I wrote the steps here just so you have a visual and a reference to know what we're going to do in each section. So let's begin. The first thing I'm going to do is just rewrite the equation here. And we want to first factor our two terms in front here, the ax squared plus bx. So from that, we can take out a 2x from both of these terms, and inside this will be left with an x here and a plus 4 over here. Okay, so that's step 1. Step 2, we're going to set y to c. So we're going to set this y value, because remember, these are just variables. It could be any value. In this case, we're going to set it to the same value as c, and this allows us to eliminate this value. So it's going to look something like this. And then what we're going to do is we want to move this over to the other side, and that's going to cancel out that y value there. So we're going to do that, and we're going to get something that looks like this. You could skip this step if you know what we're doing, but just so you can see it, I'm going to do it for you. This is going to become 0, and this is going to become 2x, and then x plus 4. Now, for this to be true, either this part has to be 0 or this part has to be 0. So that's why we can say either 2x is equal to 0 or x plus 4 is equal to 0, just like we did with our other factored form. And then, in this case, x is either going to be equal to 0, or if we move this 4 over here, x is going to be equal to -4. So one thing to note, that these values here are not our actual x-intercepts. These are just 2 points on a parabola that are across from each other. Okay, so it's not necessarily our x-intercepts. Okay, they're not at all our x-intercepts, we should say. Okay, but because we know these 2 points, we can still solve for our axis of symmetry, and then everything else will work. So let's go ahead and continue. We're going to use the midpoint formula to solve for our h value. So x mid is equal to x1 plus x2 divided by 2, and we're going to use these values here. So 0 plus -4 divided by 2, which is -4 divided by 2, which is equal to -2. So x mid is equal to -2, and that's our h value of our vertex. Now, to solve for our y value, I should say to solve for y here, we're going to use that number, -2, and plug it into the original equation here. So we know y is equal to 2 bracket -2 squared plus 8 times -2 plus 5. Okay, and so let's go ahead and do that. We have this here is going to be, I'll just solve this one. -2 squared is going to be +4. This is going to be -16, 8 times -2, and this is going to be 5. So let's continue here. 2 times 4, you know that's 8. So 8 minus 16 plus 5. And just going across, 8 minus 16 is -8 plus 5. We get a y is equal to -3. So our vertex, so this is going to be our k, our vertex is going to be at -2, -3. Okay, that's our h and that's our k value. So once we have that, it says here in this question, put it into vertex form. So let's write the skeleton equation for vertex form. Y is equal to a bracket x minus h squared plus k. And so you may be wondering what our a value is. We know that it's always going to be the same number that's in front here. So we know a is 2. We know our h value. We solved that. That's -2. So it's going to become +2 here, you know, the double negative. And then the k is -3. Okay, so that is our vertex form of the quadratic. And now we just have to graph that for this last part of the question here. So all that's left here is to graph. And we're going to use our technique that we used before to do our translation of points. We know from our parent function, our x and y values that we usually look at, -2, -1, 0, 1, and 2, and 4, 1, 0, 1, and 4. And if you remember the translation, let's write this up here. It's going to be x plus h and ay plus k. A times y plus k, and let me just write down what all those numbers are. For a is equal to 2, our h is equal to -2, and our k is equal to -3. Okay, so let's do the first one here. So x, we'll take the x from here, -2 plus h, which is -2. That makes it -4. And then the trick with this one, we just add +1 to all of these. So it'd be -4, -3, -2, -1, and 0. And then let's calculate what a times y plus k is. We know a is 2, our y from this list is 4, and our k is -3. So 2 times 4 is going to be 8, and -3, that's going to be equal to 5. This is going to be 5. And then we'll try 1 here. So 2 times 1 is 2, -3, that's going to be equal to -1. Then we're going to plug 0 into here. So 2 times 0 is 0, minus 3 is minus 3, and then they're just going to repeat, negative 1 and 5. So now we can plot our points here. So let's go ahead and plot our points here. So we have when x is equal to negative 4, y is equal to positive 5. That's going to be right here. When x is equal to negative 3, y is equal to negative 1. So it's down here. When x is equal to negative 2, y is equal to negative 3. That's our vertex. Then when y is equal to negative 1, x is equal to negative 1, y is also equal to negative 1. And finally, when x is equal to 0, y is equal to 5. And there we have our new plotted graph. And this is example 3. Just a warning, this is a kind of complicated question. And it's a thinking question. So we're going to figure it out. We're going to go step by step, and hopefully when you come across a question like this, you'll be able to answer it. So we want to determine the values of a and b here in this equation. We don't know what they are. And we do know that h and k, our vertex, is located here at 4 and negative 5. So we want to determine the values of a and b in this relation. Y is equal to ax squared plus bx plus 7. Okay, so the first thing we're going to do is we're going to start off by writing out what we know about the vertex form of this equation. So we know y is equal to ax minus h squared plus k, and if we fill in our values for h and k, we'll have something like this. Y is equal to a bracket x minus 4 close bracket squared minus 5. Okay, so that's my first step. The next thing is we need to solve our a value. And to do that, we need a good point. You may not think we have a good point, but we do, and we have it from this equation here. We can find the y-intercept. We don't actually need to find it. We know the y-intercept is going to be this value here, is 7. So when x is equal to 0, y is equal to 7. If you plugged in 0 for x, you get 0 squared times a, which is 0, and then b times 0, which is 0. And so all you'll be left with is 7. I won't do the calculation here. I'll just show you what the y-intercept is. So now we could use this point, and we're going to plug that into here to solve for a. Okay, so we know y is equal to 7. And we know when x is equal to 0. Okay, and so we're going to get something that looks like this. Let's clean that up. So 0 minus 4 is just going to be minus 4. Okay, and we're just going to move things around, and we're going to solve for what our a is. So we're going to move the negative 5 over to the other side, so it becomes 7 plus 5. And at the same time, I'm just going to square this negative 4. So negative 4 squared is 16. Okay, and 7 plus 5, that's 12. It's going to be a times 16. And then what we're going to do to get a by itself, we're going to divide both sides by 16. And we're going to get a is equal to 12 over 16, and this can reduce nicely to 3 over 4. So we know our a value now. Okay, so we're going to have to go back and start filling in our equation here. So we know at this point it's going to look like this. So a is equal to 3 over 4, and we're going to plug it into the standard form here. Now we need to figure out what b is. And so to figure out what b is, we're going to actually plug in this x and y value back into this equation here and solve for what b is. Okay, so we know when our x value is equal to 4, our y value is equal to negative 5. So wherever we see an x, we're going to plug in a 4 into this one, and wherever we see a y, we're going to put a negative 5. So it's a negative 5 up front. Is equal to 3 over 4, and we have our x here, which is 4 squared, plus b times 4, plus 7. So we're going to get that. And so we're going to start cleaning up some of this here. Okay, so let's move over the 7 over to the other side. So we're going to get negative 5 minus 7 is equal to, let's solve what this is. 4 squared is 16. So this is 3 over 4 times 16 plus b times 4. This is going to simplify to negative 12. This here, 3 times 16, if you plug this into a calculator, that's going to be 48. Divided by 4, that's going to be 12 plus b times 4. Okay, so now we're going to move this 12 over to the other side. So we have negative 12 minus 12 is equal to b times 4. So negative 12 minus 12 is negative 24. Is equal to b times 4. We're going to divide both sides by 4. And we're going to get b is equal to negative 6. So now we have our a and our b. So we have to use both equations, going back and forth between them and filling in what we know. But we were able to solve our a and b in the end here. And so we can say, if we're stating our final equation here, we'd say y is equal to a, which is 3 over 4x squared minus 6x plus 7. Okay, so that is how you do that question. There will be one question like this in the homework, just using different numbers. So you can try an example like this when you go to do your homework. See if you can get the answer. Check the back of the book just so you can see that you got everything correct. Okay, so that's it for now. This is our last lesson of this unit. So this is going to be the most complicated thing. When we start our next unit, it's going to start off easier again. So no worries. So try it out, guys.